Okay guys, let us look at this. It's the next one. Hooke's law 21. How does the numerical value of the spring constant K for a spring under compression compare with the value of K for the same spring when it is stretched? Well, we know that it's the same. Okay. Let's quickly look at this graph here. We'll get back to this in much more detail. But this is the regime or the region where the spring is being stretched, and this is the region where it is being compressed. As you can see, your x minus x0, well, if you have a spring and that's its, remember that is its relaxed position, there's no force being applied to the spring, then you could either compress it, okay, or you could stretch it, okay, if that's its relaxed position. So there it's been compressed and there it's been stretched. So you got x minus x0, x minus x0. In this case the x is negative, okay, so you're going to have a negative x minus x0 value here. In this case your x is, sorry, let me rather say this, your x is not negative, your x is smaller than x0. So if it's smaller than x0, that means that it's going into this region here, which means that this x minus x0 is going to be negative, whereas in this case your x is larger than x0, which means you're going to be in this region here. Okay, but the point is that the slope is the same in this in the compression region and in the stretching region, so long as we are in the elastic range, right? There's your elastic range. Okay, as you can see, if you keep compressing, it bottoms out. So you keep applying a force, but it doesn't. If you keep applying a force more and more in that direction, eventually it won't compress anymore. So you can keep applying the force. The force can keep increasing in this direction, but the deflection, the deformation will remain the same. It'll bottom out. Okay. So as long as you remain in the elastic region, both compression and tension, the spring constant will be the same. Okay. 22. Equation 820 relates the force exerted by a spring, by the spring on the load, to the displacement of the spring's free end. Okay? Right? Equals minus, so the force by the spring is equal to minus k x minus x0. What is the meaning of the symbol x0? This x0 is simply the length of the spring, like I just mentioned. It's the length of the spring when there's no forces being applied to it. It's in its restored, relaxed equilibrium position. Okay? That's easy enough. 23. What is the physical significance of the slope of the curve in Principles Figure 8.18? A graph that plots the displacement of the free end of the spring as a function of the x component of the force exerted on the spring. This is it. Okay? So let us erase that quickly. So what is the significance of the slope? So you've got the displacement of the free end, x minus x0, as a function of the force applied to the spring. Remember, I'm going to repeat this a few times, I think, if I remember. If you've got a force this is a force of an object on the spring, which is what we're looking at here, and then at the same time you are going to have a force of the spring on the object, and the force of the object on the spring is the negative. Let me rather write it like this. The force of the spring on the object is the negative of the force of the object on the spring. Okay? So, if we have, this is the thing, if we have the deflection or the displacement on the vertical axis as a function of the force of the object on the spring, then this slope is the inverse of the spring constant. This slope is then 1 over k. It is 1 over k. If you've got this on the vertical axis and this on the horizontal axis, then the slope is 1 over k. But now let's look at a few other ways to draw this, which I prefer. If we switch around those axes, let's call this force, and let's call this x minus x0. If we look at this curve right there, this curve would be the force of the object on the spring. Okay, so remember, they are directly proportional. Say now we've got force and deflection. Okay, then this line over here, this straight line, which has a positive slope, okay, this refers to the force of the object on the spring. Why do I say that? Because if the force of the object on the spring is positive, then the deflection of the spring also will be positive. So both these will be positive. So then you will have FOS is K, because this slope then is K, right? K, x minus x0. However, let's use another color, say blue. This slope, if I can draw it properly, good, it worked. This slope is the slope of the force of the spring on the object. Okay, which is force of spring on object, which is minus k x minus x0, because as the spring is stretching, the spring force is opposing it. It is negative. As the x minus x0 is positive, then the spring wants to restore it. So it is negative. And when the spring is, the x minus x0 is in that direction and it's negative, then the spring force will be positive. Okay? So this slope then is negative k. Alright? Another way of looking at it is just simply that, as I said earlier, if spring on the object is the negative of the spring of the force of the spring on the object is the negative of the force of the object on the spring. So then this just simply becomes the negative of this, negative k x minus x0. Okay. Are we done with these? Okay, we're done with Hooke's law.